Hello, everyone. I'm Rihanna Bag, Editor-in-Chief at Machine Design. I'm so delighted that I have three people from Sky Automation joining me today. Sky Automation is a mechatronics-based solutions provider for precision industrial automation, and their services include things like machine vision, sensing, actuation, vision-guided robotics, automatic controls, and safety applications. I'm so glad you're here. I'm going to ask each of you to introduce yourselves. Maybe we'll start with you, Evangeline.
Hi, yes. My name is Evangeline Dryburgh. I am a co-op student here at Sky Automation. And here we specialize, like you said, in vision-guided robotic systems and automating projects for clients all across the world. Right now, in particular, I'm working on robotic programming and also vision systems here at Sky Automation. So really integrating those two together. That's mainly what I've been focusing on.
And on to the right of you, we have Najma Latif.
Yeah, that's right. I'm Najma Latif, and I'm working as a software developer at Sky Automation. I basically do the mainstream programming for robotics as well as the front-end HMI designing and integration of various systems. Yeah, so just like Evangeline said, we had been servicing worldwide for many clients, creating automating projects and integrating vision into that.
And then we have Amy Spenser. What do you do, Amy?
Yes, my name is Amy Spenser. I'm also a co-op student for the summer, and I'm working very closely with Evangeline on doing robotic programming and also vision integration.
Now, I heard that you're working on a specific project on a 2.5D vision. 2.5D vision, correct me if I'm wrong. Please introduce the project to me.
Yeah, so 2.5D vision is something really exciting that we've been working on. We wanted to find a way to have our robotic system integrate with our vision system in a way that was very precise. And we found in one particular project that the taller the objects got, the more distorted the image we got back from our camera was. We were using a typical 2D camera, and integrating a 3D camera would have been a lot more expensive and time consuming. From the height of an object, we can get rid of that distortion and we can tell the robot exactly where something is, no matter how tall it was. And it just allowed us to be a lot more precise.
So tell me more about the project. Tell me about how you went about solving the problem.
We knew that we wanted to pick all of our parts off of a flat plate. So we had this flat plate and we took a series of points from it.
We started off at one height, which would be the typical pick height for our application. And then we brought it closer and closer to the camera. First, we started off with two different heights, and we plotted all that data using MATLAB. Unfortunately, that didn't tell us much, so we kind of had to change our thinking. So we went back, we got some more data, we had a third height now, and then we moved over to Excel and we again plotted it. So this is all of our data plotted out. So the different colored dots, we have green, orange, and blue, and each of those will represent a different height. And as you can see in the center, they're stacked almost one on top of another. And so that means that at each of those heights, it's thinking the part is in the same spot at each height. As you get closer to the edges, you see a lot more distortion. So our robot would think that a part is slightly to the left or to the right of where it actually is.
So we were sending incorrect points originally to the robot, and we were seeing that when it was going to pick it, it would be a millimeter shifted up and to the right or up and to the left. So we realized that we needed to find a way to fix that, and that's how we created 2.5D. That was kind of an in-between of taking our 2D image and creating a rudimentary third dimension with that information.
So when you say 2.5D, it's not very common, right? So people might have heard about 2D and 3D, but not 2.5D. So that's what the name we gave it, because it's more precise than a 2D, but then it doesn't create any 3D images. So that's why we call it 2.5D. And Amy and Evangeline were specifically talking about how robot was not picking parts accurately as it was supposed to. But then in a broader concept, if you see, vision is not just for robotics. If you see in today's world, vision is integrated almost everywhere, like in medical field, like for surgeries, where like it's in automobiles, it's in a lot of places. So developing this algorithm is a very important and a very valuable thing that Amy and Evangeline has done. Like they have contributed a lot to it, and it can be very useful in various applications.
Sky Goter is president of Sky Automation, and he's joining us now to give us a bit more background on the project, that on the 2.5D project that his team is working on. Welcome.
Thanks for having me.
I was very impressed with your team and the efforts that they put in to create such an innovative project. Tell me a little bit more about your co-op program.
So I want to say I'm really proud of our team as well. We've been using co-op or been involved with the co-op program for quite some time. I think since 2018, we had our first co-op student. But I think it's migrated or progressed to be something that we're very ambitious with. So with the mechatronics students that we have now, they came in this term having never programmed 6-axis robots or vision systems. And before the end of their term, they're calibrating and programming vision-guided robotics. So as a team, we're really proud to be able to give people that opportunity to work with this level of technology. But it's also encouraging to see how well they're doing and migrating to these technologies, which I think is a testament to the programs that are available for students now.
No, I agree. At the same time, you do run a business after all. So to me, any project that you do needs to have real world application. So I was hoping that you could contextualize for me what this means, this 2.5D value added project. What does it mean for your business?
So I'm excited about this because, of course, 2D vision's been around for a long time, and of course 3D and bin picking type applications are very common, but there is kind of a gap where with a lot of the vision guided robotic systems that are available, there's these precision issues related to traditional 2D imaging. And so with this advancement or this innovation step, we're able to, at a very low cost, introduce the next level of precision to these vision-guided feeder systems. One of the first projects we did as a corporation was vision-guided robotics, and we've, over time, seen the opportunity to fine-tune the process and to fine-tune the mechanical and opto systems so that we can achieve better accuracy without more sophistication or more cost.
And tell me a little bit more about just the whole process of putting your, co-op students through the process of learning. How do you bring them along?
We try to do it incrementally. So, of course, the first step is just introducing to a robot and showing them some examples of code that we've done in the past and having a new development done. So it's traditional point-to-point type programming, but we migrate quickly when the student shows potential so that we're doing more of a continuous motion, understanding how to optimize motion paths, as well as to do more advanced functions within the robot controller, so that we really try to help them appreciate that if you can think it, it can be done. And giving them the tools as well as the support and leadership to be able to achieve those goals as they develop really an industrial automation system.
Mm-hmm. So I also asked them about the 2.5D vision project that they are working on and how it relates to a specific project that in the market. Can you speak to that? Tell me, how is it being applied?
So over time, we've really seen applications that demand precision and reliability. And so, of course, with 2D imaging, due to the optomechanical system, the focal distance affects the way the image is presented to the guidance system. So by applying algorithmically a scatter plot to the calibration routine, we're able to algorithmically adjust for those height changes on these parts. So we're talking about traditional vision guided feeder systems that are very common in the market today. Products like Flexible and AziCube and FlexFeeder. These systems are presenting a really nice solution to the market, but there seems to be a bit of a gap where they're designed truly for flexibility, but we lose on the precision a little bit when it relates to dimensional changes in the parts. So that solves this problem, and it can be applied accurately to any of those systems.
That's pretty amazing, and to my mind, immediately means cost savings to someone who's already had a system in place. Am I reading that correctly?
Yes, not just the cost savings, but also higher reliability and greater degree of flexibility on a system that's really designed for flexibility to begin with.
Sky, thank you so much for insights on 2.5D vision.